Hello and welcome back to Introduction to Astronomy. Today we're going to be doing a lab on telescopes. So you're going to want to go to Canvas, Modules, Labs, and then the Unit 1 Labs on Astrophysics. Then down at the bottom you're going to click on the tab that says 4 telescopes. So we're doing lab number 4 on telescopes. Okay, first thing you're going to do is read the concept introduction. Okay, and then after you have done that, then you're going to answer the pre-lab questions. So your pre-lab questions are: define the following terms. So you're going to define what reflection is, define what refraction is, and define what diffraction is. Okay, then on question number 4, you're going to draw a picture of a concave mirror. So what I want you to do is go to the internet, type in the word concave mirror on Google, then go to images and pick any of those pictures that shows what a concave mirror looks like, copy it, and then paste it into the document. On question number 5, it says to draw a picture of a converging lens. So go to Google, type in the word converging lens, find an image of one, and then paste it into the document. Okay, so now let's go down to the actual lab itself. Now we're having to modify the lab because you're probably not going to have all of the different things that are in the lab itself. So need to pay close attention here. Okay, so I'm down to the procedure, and the first thing that I want you to do is reflection, and for that, obviously, you're going to need some kind of mirror. And it doesn't really make any difference what the size of the mirror is, and you're going to hold it about 6 feet from your face, so that means that you're probably going to have to maybe prop it up on a chair or something, and then look into it. But you're going to describe, is your size of your face, is it large, is it small, is it normal sized, and then the orientation of your face, is it right side up or is it upside down? Okay, now the next thing that you can do with your mirror, but I really don't recommend it, is to gently bend the mirror and see what it does to your image. So if you've got an expensive mirror, don't go bending it because you'll probably crack it and maybe cut yourself on it. So you don't necessarily have to do that part. But the point is that a flat mirror can be curved into either a concave mirror or a convex mirror. So I don't expect you to have a nice concave and convex mirror like we use in labs, but I do expect you to have a spoon. So if you get out a big spoon, one side of this is going to be concave, and then the other side of it is going to be convex. So it's up to you to figure out which one's which. So if you've done the pre-lab, you know what a concave mirror looks like, and you know what a convex mirror looks like. So you're going to look into the convex mirror, and again at a distance of about 6 feet, and then look at yourself. Are you large or are you small in that mirror, and are you right side up or are you upside down? And then I want you to walk towards that mirror. So get it right up to your face and see if anything changes when you do that. Now I want you to repeat the experiment, but this time using the concave side of your spoon. So you're going to start about 6 feet away from the spoon and see if you can spot your image in it. Is it right side up or is it upside down? Is it large or is it small? And then walk towards it, and you have to get it right up to your face, I think, before you would see something happening. But something will change this time with the concave mirror. And if you don't know what you're looking for, all you got to do is go to Google and type in concave mirror, what happens to your face, or something like that, and then go to videos. So take some time on the internet and find a video that illustrates what I'm talking about, if you can't see the effect in the spoon. Okay, so that is reflection. Okay, now we're going to do refraction. Now the original thing in the lab called for having a flat piece of plastic that it's in the shape of a square, and it's about 1 inch thick. And then what you do is you look into the side of it, and then you put a pencil behind it, and then you turn it back and forth, and you should be able to see the pencil is broken. And that effect is caused by refraction. Well, if you don't have that, you can substitute an aquarium for it. So if you're looking into an aquarium and then you take a pencil and you put it behind the aquarium and then you move your head back and forth, you should be able to notice that that pencil becomes broken because of the effects of refraction. Now, if you don't have an aquarium, you've got a glass. I know you've got a glass at home. So you could take a glass, fill it up with water, take the pencil, put it in there at an angle into the water, and then observe how the water bends the pencil. So that's all examples of refraction. Okay, then let's go down to, let's see. I think I'm going to stop right there, and when I come back in the next video, we're going to talk about taking that flat piece of plastic and bending it like we did with the mirror. Okay, so that'll be in the next video.